So what I'm going to do right now, guys, is I'm going to go all the way back to the beginning of Unit 4. I'm going to really quickly review for you guys electron configuration using the periodic table, valence electrons, charge, and Lewis dot structure. So if you guys had any issues with your Unit 4 test, this is a great video for you to watch. Alright? So, really quickly, really nice trick for us to use is the periodic table for deciding our electron configuration. So what I'm going to do is show you that actually this block right here, so groups 1 and 2, that is what I call my S block. Okay, and so I'm going to color it just with green. Okay, and remember, hydrogen's included in that in addition helium is, so I'm going to color in helium as well. Okay? So that is what we will label our S block. Okay? On this side right over here, okay, as you'll remember, you have 1, 2, 3, 4, 5, 6, both protons and electrons represented by each block. So 1, 2, 3, 4, 5, 6, well, the orbital that has 6 electrons in it is your p orbital. So I'm going to color this entire block. This is your p block right there. Alright? Awesome. Alright, let's look really quickly now at the center. That is our D block. So I'm going to take a purple. It's not showing up as well as I would have liked it to. But the center, that is our D block. And there, if you count all the way across, there are 10 blocks all the way across. And so that is our D block. Okay, and the very bottom, right here, is our F block. Okay? And so the way that we're going to write our electron configuration, we're going to, remember, we just read it like a book. Okay? We label our rows based off of our principal energy levels. So our first row is row 1. This is our first principal energy level. Here is our second principal energy level, third, fourth, fifth, sixth, and seventh. And so we're just going to read across until we hit the element that we are trying to find. So the element, let's say for example, that I want to find is aluminum, which is right here. I'm going to put a star next to aluminum. Okay, so we have to start with hydrogen and read across and then go to the next row all the way across, then to the next row and all the way across until you hit aluminum. Okay, so what you're going to do for your electron configuration, you start off, this is 1, so it's 1s. Okay, and it's 1s, well, you have to decide how many electrons there are in that orbital. So let's look really quickly. Alright, you've got 1s, well, you've got one block here, and you've got the other block, well, it doesn't really show up very well, but it's helium's your other block. So you've got 2 electrons in your 1s, and all s's only have 2 electrons. So there you've got 1s2. Okay? Now we're going to go ahead and go to your next row, because you finished with your 1s's. Okay? Now you're going to go to 2s, and you've got 2 blocks in your 2s. So I'm going to write 2s, 2. Okay? Go all the way across to your p's, and your p's are going to start all over again. Okay? Your p, you're still in your second row, but now you've got 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. So a total of 6 in your 2p. So I'm going to write that down. Okay? And let's keep going. Now I'm in my third row right here, and that's 3s. I've got 1, 2, so it'll be 3s2. And finally I hit aluminum. So that's going to be 3p. And I've got 1 electron in my P. Alright, and I'm done. Okay, so that was a review of your electron configuration. So that's your electron configuration of aluminum. Let's really quickly review valence electrons. Okay? What valence electrons are are your number of electrons in your outermost energy level. Well, your outermost energy level for aluminum, let's do aluminum really quickly, okay, is your third energy level. So you've got that here and that here. You've got two different energy levels. Now, in your 3s, you have 2 electrons. Okay? In your 3p, you've got 1. So if you add these electrons up, you've got 2 plus 1. You have a total of 3 valence electrons. Now, what we did in class is we worked all the way across our periodic table, starting with group 1, then going to group 2, then going to group 3 where aluminum is, 4, 5, 6, 7, 8, all the way across. And we wrote out the electron configurations and decided how many valence electrons each of them have. And it's actually really, really nice because what we found was that group 1 has only 1 valence electron. Okay, so I'm going to write at the top, 1 valence electron. Group 2, okay, this entire group, and remember groups are your columns, periods are your rows, so this group 2 has 2 valence electrons. Alright, if I go all the way across, jump over and skip over your D block, ignore it guys. Okay. This group 3 has 3 valence electrons, group 4 has 4, then 5, then 6, then 7, and then 8. Okay? And remember, the ultimate goal is for your element to have 8 valence electrons. And so your noble gases, and when they have 8 valence electrons, they're stable. So your noble gases are extremely stable. Okay? And all your other elements want to get that perfect octet. We call it an octet. Okay? So what we're going to do right now is look at what happens, why, and how your elements get a charge when they become ions. Okay? So let's start off really quickly with your 7 valence electrons right here. Okay? Alright, so if you have 7 valence electrons, okay, you either want to lose all 7 of those valence electrons, because if you lose those 7, if you look, let's say with fluorine, okay, we're going to start right here. Fluorine, you would lose 1, 2, 3, 4, skip over here to beryllium, 5, 6, 7. It now has the electron configuration of a noble gas. So it can either lose 7 or just gain 1 to become a noble gas, to have the electron configuration of a noble gas. Well, losing 7 is a lot harder than just gaining 1. And so what this entire group does when it has 7 valence electrons, it just gains 1 valence electron. And here's the tricky part, which a lot of people are having issues with. If you're gaining 1 valence electron, that means you have a -1 charge. Okay, so this entire group has a -1 charge. Okay. For group 6, okay, that has 6 valence electrons, okay, it can either lose 6 valence electrons or gain 2. So it's a lot easier for it to gain 2 valence electrons than for it to lose 6, so it's going to have a -2 charge. Okay. For 5, okay, and ignore the P, that was just for the group. But for 5, it has 5 valence electrons. This whole group has 5 valence electrons. Okay, and so as a result, it would rather gain 3 valence electrons than lose 5. So it's going to have a -3 charge. Okay. Now the challenging part for here, 4, well, is it easier to lose 4 valence electrons or gain 4? Well, it's equally as easy. So it's going to be plus or minus 4. Okay, and that's a funky charge, and we'll discuss it later. It causes some issues, okay, but you're okay right now. Okay. If you have 3 valence electrons, you either need to gain 5 valence electrons or lose 3. So it's actually now, finally, easier to lose 3. So if you're losing 3 valence electrons, you actually have a +3 charge because you're losing a negative charge. Okay. Let's go over to 2 valence electrons. This would have a +2 charge because you're losing 2 valence electrons, and for 1 valence electron you would have +1 charge. Okay, so we've dealt with charge, alright, and valence electrons. And the last thing we're going to be talking about in this video is your Lewis dot diagram. Okay? So, let's talk about that really quickly. Your Lewis dot diagram is just a way to demonstrate how many valence electrons an element has. And so what you'll do, let's say for example I ask you to draw the Lewis dot diagram of magnesium. Okay? And so what you'll notice is magnesium is located right here. Okay? So it has 2 valence electrons. So all you need to do is to write the symbol for magnesium, which is just Mg. Okay? And then around it, all you're going to put is 2 dots, and each dot represents 1 valence electron. So you're going to put 1 dot and a second dot. Okay? And just as what I talked about when we were talking about valence electrons, the maximum number of valence electrons you can have is 8. Okay? And so, for example, if I were to write the electron configuration of argon, okay, which happens to be, if I can scroll up, to be a noble gas, okay, I would write Ar, alright, and it would have 8 dots. 1, 2, 3, 4, 5, 6, 7, 8. So that's the maximum number of valence electrons you can have at a time. Alright? You can't have any more than that. You can definitely have fewer, and I really don't care how you write it as long as you don't have more than 2 on either side, up or down, on either side of the element that you're dealing with. Alright? So what I would recommend, if anyone's having issues with this, I would recommend doing a little bit of practice. I'm going to post a couple of extra practice problems on the review for finding number of valence electrons and working with charge. Make sure, guys, that you're practicing this if you're having issues, because it's fundamental for this unit that we're working on with ionic compounds. Okay? That's the end of this video. I will see you guys later.